So guys, in the last class we have seen that when a particle is moving perpendicular to the magnetic field, then that will create a circle. I mean that will move in a circular motion, right? Now and we have tried that what is the R, what is the kinetic energy. Kinetic energy will be half mv square. We have tried that radius will be mv by qb. The where mv is the uh, what is mv? That is momentum, right? So now yesterday we have seen that also that if this is the magnetic field going inside, if a charged particle goes here, so it will come in the same angle. If this angle is theta, that particle also comes with the angle theta only. Okay. So now today we are going to see that that if this magnetic field is in only on a strip, like if it is very less, so how this will deviate like this. See, whenever a particle enters in a magnetic field, let's say that the thickness of the magnetic field is d. If the particle enters in a magnetic field, it will try to create a circle, but it will not be able to create the circle. So it will go from the magnetic field by creating angle theta. We will see that how much angle it will create and all this we will see here. But before going to that, let's do some question in this particular topic. Okay, so let's do one question here. Write down the question, guys. This is the magnetic field going inside. So magnetic field is inside like this, right? Okay. So a particle is moving with some velocity v. Okay. It just projected with some velocity v, and it is coming out with some velocity, let's say v only, and the theta here is 45 degrees. Okay, so here also it will make 45 degrees. Okay, the particle going like this and it is going out. Okay, now you have to tell me what is the time spent. What is the time spent? Time spent here to here. Okay, and you have to tell me what is this distance. Let's say EF. What is EF? How is the distance EF? And what is this angle? This angle. Okay, this angle you have to tell me. Like it is alpha. What is alpha? If the magnetic field is 1 Tesla, B is equal to 1 Tesla, and velocity is, let's say, how much will be the velocity? Let's say it is 10 raised to power 7 meter per second velocity, and the charge is let's say Q is 8 microcoulomb. Okay, fine. Find it. Find this. Just one more case. Let me change the values. Actually, it is a proton. Okay, the mass of the proton is 1.6 into 10 raised to the power minus 27 kgs, and the velocity will be how much? Velocity is 10 raised to the power 7. Already we have seen 10 raised to the power 7, and charge is 1.6 into 10 raised to the power minus 19 coulombs. Okay, this is the charge. Okay, charge is 1.6 into 10 raised to the power minus 19 coulomb. Mass is 1.6 into 10 raised to the power minus 27. B is equal to 1 Tesla. B is 1 Tesla. Okay, velocity is 10 raised to the power 7 meter per second. Find out the value, time spent in the magnetic field, and what will be this distance here, and what will be this angle alpha. You have to find. Okay, just find out the answer. So now I am going to solve this question, right? So guys, first of all we will find the alpha. So how we will find the alpha, guys? Obviously this angle will be 45. This will be 45. Yesterday we have seen in the lecture. This is 45, this is 45. So it will be obviously 90 degrees. Yes or no? See, we have this triangle. This is 45 degrees. This is 45 degrees. Obviously it will be the 90 degrees. Okay. So alpha is equal to 90 degrees. Second, we will find EF. To find the EF, we have to find out the radius. Right? So how we will find the radius? That is, tell me, MV by QB. Yes or no, guys? So what is MV? So tell me, what is mass? 1.6 into 10 raised to power minus 27. What is V? 10 raised to power 7. What is charge? 1.6 into 10 raised to power minus 19. What is B? That is 1, right? Okay. So 1 cancel. So it will be how much, guys? R equal to 10, 20, 10, 10. I think it is 0.1 meter. Am I right? Am I correct? Tell me, guys. 20 plus 90. I think I am correct. This 20 meter, or we can say 10 centimeter, right? Okay. So what is this one now? This is radius only, right? This is radius only. So it is like this. So this is 0.1 meter, 0.1 meter. So obviously it will be root 2 0.1 meter. Yes or no, guys? Root 2 into 0.1 meter. Yes or no? This is triangle, simply triangle it is. Yes or no, guys? If it is 0.1, it is 0.1, it is 45 degrees. It is 45 degrees. So it is root 2 into 0.1. So EF will be how much, guys? EF is equal to how much? Root 2 into 0.1. I think it is 0.141. Okay, 141 meters, or can I say 14.1 centimeters. So EF is equal to 14.1 centimeter. Anyone of you got this answer? 14.1 centimeter. Anyone? Okay. Now let's find out the time span. See how much angle is there. How much angle it is covering? 90 degrees. So time, let's find out the time. Time is how much, guys? 2 pi r by V, or r is equal to mv by qb. So it will be how much, guys? 2 pi r is value, r value is how much, guys? We got r value 0.1. Okay, what is the v velocity? That is 10 raised to power 7. So how much it will be? Just find out the answer. How much it will be, guys? Time spent. This is the total time, right? So okay, now this is the total time, right? For 90 degrees, it will be the time spent into 90 degree by 360, or t into pi by 2 by 2 pi. Okay, means if it is angle theta, this angle is theta. Okay, so total time spent will be total time into theta by 2 pi. In the same way we are doing it like that. So what is time period? That is 2 pi into 0.1 by 10 raised to power 7 into pi by 2 into 2 pi. Okay, so pi and pi will be cancelled. So the time is equal to 0 pi into 0.1 by 2 into 10 raised to power 7. So time spent will be how much, guys? Just find out the answer. It will be, so pi into 0.1 divided by 2 into 10 raised to power 7. So it will be 1.5 1.5 into 10 raised to power minus 8 seconds. This will be the time spent. Okay, so take this guys fast. So I'm going to reverse the charge, then you have to find the answer. Okay, just first you take this down. So now guys, you will see if the magnetic field is reversed. When we will reverse the magnetic field, then what will be effect in the trajectory. Okay, so let's say now we reverse the magnetic field. Okay, so this is the magnetic field. Okay, it is now coming out. It is the B. Okay, it is coming out like this, coming out of the plane, and it is constant. Okay, now if you see, if you throw it by 45 degrees angle like this, if you throw it by the 45 degrees angle, what will happen here? See, it is 45 degrees angle. So now it has to come with the same angle. If you see, the velocity is here and the magnetic field is outside. If you see, where will be the force? See, this is the velocity direction. Curl your finger in the direction of the field. So force will be this side. Means force will be like this. Force will be like this. So it has to come out of the 45 degree angle. So it will cover most of the circle inside the field only, and will again come out with the 45 degrees angle here. Okay guys, so again we will make this triangle here. So this is 45 degrees angle. Okay, this is 45 degrees, this is 45 degrees. So it is how much guys? 90 degrees. So it will be how much? 270. 270 is how much? Tell me. It is, I think, pi plus pi by 2. Okay, pi plus pi by 2. See, actually it is like this. See, it goes like it is coming like this. Okay, see, let's say it is going like this. See, so this is pi by 4, pi by 2, this is pi by 2, this is pi by 2. If you see carefully, this angle is pi by 2 here. This is pi by 2, means this angle. Means you can make it like this. Okay, so this is pi. So this is pi by 2, this is pi by 2, this is pi by 2. So this is pi by 2, means total is 2 pi. 2 pi, right? Total is how much? 2 pi. And this angle is how much? This much, this much, this will be 2 pi minus pi by 2. Actually it is same, pi plus pi by 2, same. How much you will get? 4 pi by 3. So it is 3 pi by 2. 3 pi by 2. It is also 3 pi by 2. Okay, no, yes, correct. Okay, so actually it is a 3/4 of the circle. It is 3/4 of circle. Okay, it is the 3/4 of the circle, right? So if you want to find out the time spent here, so what is the time spent total? Total time spent was, tell me guys, 2 pi r by v. Okay, okay, but here you see the radius will be how much? Radius will be same, because r is equal to mv by qb. R is equal to mv by qb. In the first case, in this case, the radius will be same. So directly you can find out the radius. Okay, or we can find out the time period. So now the time period for this angle, let's say this is alpha. So time period for the alpha will be how much? What is the alpha angle? 3 pi by 2. So it is 2 pi r into v into what is the angle guys? 3 pi by 2. 3 pi by 2 by 2 pi. Right? So it is, so 2 pi will be cancelled. Okay, here. So now we have left with 2 pi r is equal to 3 pi r by v. by 2v. Okay, you can find the time period. You can get the time period, whatever the time period, just find it. And here EF will also be same, I think. This is 45, this is R, this is R. EF also will be same here. Whatever we got in the last. Alpha is equal to here. How much alpha is there? 3 pi by 2. Okay. So got the point or not? Tell me, guys. Did you understand this or not? Tell me, guys. So now, guys, we have completed two cases. One case was when the charge is moving along with the magnetic field or opposite direction to the magnetic field. Then there was no effect in the velocity of the magnetic field, or the path of the charge was straight line only. But we have seen a case when the particle is moving perpendicular to the magnetic field. Magnetic field is there, is this, and the charge is moving perpendicular to the magnetic field. Then we have seen that it is moving in a circular motion. Now we are going to see a case where the charge is moving oblique to the magnetic field. See, this is the magnetic field and the charge is moving like this. Charge is moving like this. Charge is going like this. Magnetic field is this. So it is making an angle theta with the magnetic field. So let's see how it will move. What will be the path of the charge? Okay. So case third is case 3. In the case 3, we will see the charge is moving oblique to the magnetic field. Okay. Let's say it is a y-axis. This is x-axis. This is z-axis. In the x-axis, there is a field. There is a field B, like this, and this is the magnetic field B, and it is B is equal to B naught I cap. What does this mean? B is equal to B naught I cap means the magnetic field is in the direction of x-axis, right? Okay. Let us suppose our charge is moving like this. Okay. So, okay guys, so B is B I naught, and let's say this velocity is moving like this. So let's say velocity is moving, let's say x I cap plus y j cap, means it is moving in 2D like this. See, velocity is like this. Velocity is like this. So this is the magnetic field and this is velocity, right? So it is making an angle theta with the magnetic field, right? Okay. So one thing we have seen that whenever the particle is along the field, then there will not be effect on the motion of the particle. But as the particle or the charge is moving oblique, and as the charge is moving perpendicular to the magnetic field, it will go in a circular motion. But here, this particular charge is having two velocities. Let's say it is a plus q charge which is having a mass m. Okay. So we know that this velocity will be having two components. Let's say one component is here. This is v cos theta, and one component is v sin theta. Okay. Can you tell me, guys, will there be any circular motion? Will there be any circular motion of the charge? Tell me, guys. This is charge plus q and mass m. Will there be any circular motion here? Tell me. See, if you see, whenever the motion of the particle is perpendicular to the magnetic field, then there will be some disturbance in the velocity. That velocity will become in a circular motion. But when it is moving along the magnetic field, there will not be any effect. But you see here, this particular charge is having two kind of motion here. One motion is perpendicular, one motion is horizontal direction along the B. But one velocity is in perpendicular direction. See here, see it is moving at an angle theta here, right? So see, this is B, it is moving like this, V. So obviously this charge is having two component of the velocity, which is making an angle theta. So one velocity component will be here, that is V cos theta. This is V sin theta, right? So we know that when the velocity is parallel to the field, there will not be any effect. But when the charge is moving perpendicular to the field, then obviously there will be circular motion like this. See, so now we can remove this one, and we have two velocities. One is along the field, and one is perpendicular to the field. So because of this component V sin theta, it will start moving in a circular motion. How? Where will be the direction, guys? If you see, this is the direction of the velocity, V sin theta, and this is the direction of the magnetic field. So if you curl your finger in the direction of the field, this will be the force. Okay, this will be the force. It means how it will go in a circular motion. See, suppose the charge is moving like this, and the field is in this direction. Charge is moving in this direction. Let's say condition is there. Charge is moving like this, and the field is this one. This is the field, magnetic field. Charge is this. So where will be the force? I think force will be like this. Keep your palm in the direction of the velocity. Curl your finger in the direction of the field. You'll get the force here. It means it will try to bend like this. At this point, force will be here. 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 At this point, force. So don't you feel it will start creating a circular motion like this? See? Are you getting my point or not? Initially the velocity was like this, but it starts doing a circular motion like this. Are you getting my point or not? Tell me. And when the field is here, this is the motion of the particle. So particle will continue to move in this direction only. Yes or no, guys? Tell me. Yes. But now this particle having two motion. One motion is perpendicular and one motion is parallel to the field. So it means one component will try to move this particle in the x-axis like this, and one velocity will try to rotate it, try to circulate it, right? Yes or no? So don't you feel it will move like this? Don't you feel it will move like this? See, the field is here. One component will try to move it in the forward x direction, and one velocity component will try to rotate it like this. Circulate it. So don't you feel it will move like this? Like this. Are you getting my point or not? So it will move like this. See, one component will drag it into x direction. One component will try to circulate it. So don't you feel it will move like this? See? Tell me. So which motion it is? What we call this motion? This motion is called helical motion. And this trajectory is what? Helical path. Are you getting my point or not? Tell me. So if you see here, so this we can say this is the V perpendicular. And this is what? V parallel. Yes or no? So don't you feel it will try to move in this direction like this? See. Don't you feel it will be moving like this? Tell me. Tell me, guys. If it is moving like this, see. So this will be the V perpendicular. This will be the V parallel. Tell me, guys. Did you understand this or not? Tell me. Yes. So let's discuss this helical path. So this helical path is like this. Yes, ma'am. Okay, 1 minute. 1 minute, ma'am. Okay, so this particle will be moving like this. See. Yes or no, guys? Tell me. So see, this V parallel is responsible to drag it in the forward direction, and this particular velocity is responsible for the circular motion. Okay. So tomorrow we will discuss. We are going to stop this class here. Tomorrow we will discuss what is the pitch, what is the radius created by this helical circle, what will be the force on this particular charge with the Lorentz force. Tomorrow we will introduce the Lorentz force. In the Lorentz force, what is the Lorentz force? Lorentz force is a combination of the electric field and the magnetic field. When there is a charge which is under the electric field as well as the magnetic field, then it will behave in a different way. We are going to see tomorrow how it will react to the magnetic field and the electric field. Okay, thank you guys, best of luck, bye.